All right, everyone. Here in this video, we have a two-part question. Now, the real question is we want to simplify the expression cosine pi over 2 minus x. And we're going to simplify that using the angle difference identity, and that will be in the next video that I post. But I did ask students to first, before they do that, take a minute and let's graph it, y equals cosine pi over 2 minus x. And sorry about that. So I'm going to graph this first, and then we're going to look at this graph and kind of compare it later on. Compare it to what we get as our simplified answer for the expression. Now, when we graph this, it's not quite in the form we want it in. We usually want x in front. So if I kind of slowly start manipulating this to make it look a little bit more familiar, like our graphing unit showed, we'll have cosine of negative x plus pi over 2. We're going to start with that. From here, it looks a little bit better, but that negative is still not really what I want. When you want to see that x minus h situation happening, the x should only have a 1 in front of it. That means this will be the first time that we have a negative, or a negative 1 in this case specifically, as our b value. So I'm going to go right here, y equals cosine. Again, there's an invisible 1 in front for the amplitude, or a, our vertical stretch. The b value is also a negative 1, well, also 1, but it's negative. Another parenthesis. Now, if I factor a negative out of both of these or divide a negative out, I have an x and I have minus pi over 2, close, close, and then technically a plus 0 at the end. Again, multiplicative identity of 1, additive identity of 0. You don't need to write those down. I'm just writing it for a little refresher. So a is 1, b equals negative 1, h, remember the formula is x minus h. So h is positive pi over 2, and then k is 0. So we don't move this graph up or down. It's going to be cosine and positive, and we move to the right pi over 2. And that negative we'll handle in just a second. So if k equals 0, that means that my sinusoidal axis overlaps my x-axis. So that makes things kind of easy. I could draw my x-axis right away. I need 5 tick marks, 1, 2, 3, 4, 5 tick marks on there. Then, gotta be careful here. So I'm gonna kind of not label on here yet. Period equals, I almost wrote pi because I was just doing tan the other day, last night. 2 pi over b, that's the formula. So period equals 2 pi over negative 1, negative 2 pi. What? How, period, that's the length. The length of it is still 2 pi, but when we graph it, this negative is telling me go to the left, don't go right. Go to the left when you put your tick marks. Wherever you start, but go that way. So then the quarter period, how much do we go that way each time? Well, for you that way, maybe? I'm not sure. So then the quarter is 1/4 of the period. So the quarter is 1/4 of negative 2 pi, which will be negative pi over 2. And that works out pretty nicely because I don't need to find a common denominator. Remember, we're going to the left. So h, pi over 2, is actually my last tick mark. The negative b value, if you remember, is a horizontal reflection. So my graph is going to flip that way, and then my tick marks will go in this direction. So pi over 2, and then I'm going to 4 more tick marks. I'm going to draw out, and I'm going to subtract pi over 2 each time. So I have 0, and then I have pi over 2, but negative. Then this is negative 2 pi over 2, or negative pi, and then negative 3 pi over 2. The amplitude is 1. Here's my y-axis because it's 0. So that means nothing really changes in that department. I go up 1 unit and down 1 unit. Oops, there we go. And cosine, I would normally start at a maximum up here. And I'm just going to kind of go down to a 0, a min, back up here, and here. So we got that and this. Now if I continued this, put a little curly tail right there, I'm actually going to draw another tick mark. My graph would look like that at pi. Then it would go again, and that would be right here at 3 pi over 2. And then at 2 pi again. So just keep this in mind. Maybe you make some, hypotheses on what you think is going on here and why, but that will be further explained in part 3. So in part 2, now what I'm going to do is actually simplify this using the angle difference identity. And then part 3, we're going to tie it all together. So that's the end of this video. If you think you understand the negative b value situation, put a thumbs up. And if you are riding the struggle bus with negative b values, put a thumbs down. So we'll do a little bit more practice with that, because I know I haven't really done many examples with a negative b value. All right, have a good day.